Hello, pre-calc students. Doing quiz 4 for sequences and series. So the first problem, it says Alexei earns 20,000 in salary in the first year of his career. Each year he gets a 5% raise. How much does Alexei earn in the first 4 years of his career? This is going to be a geometric series because Year one is 20,000. Year two is 5% more than 20,000, so that'll be 20,000 times a 5% raise. That's going to be times 1.05. All right. And then the third term would be the second term times 1.05. So the term 3 would be term 2, right? That value. Times term 2 times 1.05. So now that we recognize that this is an infinite, this is a finite geometric series, we can use our formula for a finite geometric series, and that's going to be Sn is equal to A1 over 1 minus A over 1 minus R, and the A1 is going to be multiplied by 1 minus R to the n. So first we need to identify the pattern here. So our $20,000 salary, that's going to be our salary for the first year, then the second year, the third year, and the fourth year. And here our common ratio is going to be, it's going to be increasing by 1.05. So R is 1.05. So Sn, S4, we should say, is going to be equal to A1, the salary after the first year, 20,000, times 1 minus R to the n. That's going to be 1 minus 1.05 to the fourth, all over 1 minus 1.05. And note that so let's plug this into the calculator. We will have 1. So let's first find 1 minus 1.05 to the fourth. So 1 minus 1.05 to the fourth power that's going to be negative 0.21. Then I multiply this by A1, which is 20,000. So I multiply this value by 20,000. 20,000. And remember, this whole term is divided by 1 minus 1.05. So this is divided by 1 minus 1.05. And that will give us a value of 86,202.5. So Alexei, after 4 years, gets $86,202.05. 86,202.5. Check. That was the correct answer. So we need to be able to apply our our formula for a geometric series, a finite geometric series. Priyanka wants to recreate the story of the rice and the chessboard, but she only has a tic-tac-toe board which has 9 squares. And this comes from a fable, so you can Google this. If she puts 1 grain of rice on the first square of the tic-tac-toe board, 2 on the second, 4 on the third, and so on, doubling the amount of each square, how many total grains of rice will be on the board? So 8, 16, 32, 64, 128, 256. If we wanted to, you could just add all of these up. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256. So 511. But if this was more complicated and we had more squares to put on, we wouldn't be able to add them up. Let's say, I don't know, you had 5 million squares. You couldn't just add them all up. So let's use our geometric formula. There are 9 squares, so we can say S9 is equal to A1, and our R is equal to 2, because we double each time. So each time we double, which means our common ratio, R, our common ratio, is going to be equal to 2. So S9 would be equal to A1 times 1 minus R to the 9 over 1 minus R. Here, R is equal to 2, and A1, our starting value is 1. A1 is equal to 1. So S9 would be equal to 1 times 1 minus 2 to the 9th over 1 minus 2. So we can also do 1 minus 2 to the 9th, 1 minus 2 to the 9th, times 1 divided by 1 minus 2. 1 minus 2 equals negative 1, so divided by negative 1, you can see that this will give us the same answer, 511. So there are 511 grains. Next question. Clearing annotations. Li Ji releases a pendulum. On the first swing, it passes through an arc of 14 centimeters, which each swing it passes through an arc 3/4 the length of the previous swing. When it completes the 5th swing, what is the total distance that the pendulum has traveled? Round your final answer to the nearest hundredth. Alright. So, this is another geometric series, okay, where, once again, Sn is equal to A1 times 1 minus R to the n over 1 minus R. We recognize this as a geometric series because the arc is 3/4 the length of the previous swing. So we're multiplying for each swing by 3/4. So to find the value of each swing, you can just first find the previous swing and multiply it by 3/4 because you're multiplying and not adding. This is a geometric series and not an arithmetic series. Alright, so on the first swing, it passes a length arc of 14, so that could be potential A1. And each swing, it's 3/4 of the length of the previous swing. So A1 is 14, A2 is going to be 14 times 3/4, otherwise known as A1 times R. So A1 is 14. R is equal to 3/4. We are looking for the fifth swing, so we have N is equal to 5. So A1 is 14, R is equal to 3/4, N is equal to 5. And in that case, A1, we can just plug into the equation. A1 times 1 minus R to the N over 1 minus R. We just have to recognize this is adding up all of the terms in the sequence, because what is the total distance that the pendulum has traveled? So we need to have A1, 14, times 1 minus 3/4 to the fifth power, all over 1 minus 3/4. So let's plug this into our calculator. So let's find 1 minus 3/4 to the fifth power. So we can do the calculation. 1 minus 3/4 raised to the fifth power. All right, so that's going to be 0.762. We'll find it out. That, remember, this term is multiplied by 14. 10.677, and we divide that by 1 minus 3/4. So we divide this term by 1 minus 3/4, which is 1/4, but plug the whole thing in. So that's going to be 42.71, round to the nearest hundredth, so we can plug in the answer 42.71. Let's see if that's correct. It is. Alright, sorry, announcement. Burian wants to recreate the story of the Rise of the Chessboard, but only has a backgammon board, which has 24 points. So if she puts 1 grain of rice on the first point of the backgammon board, 2 on the second, 3 on the fourth, so on. So now this is just kind of like the tic-tac-toe problem, but instead of having 9 slots on the tic-tac-toe board, we have 24. So go back to the tic-tac-toe problem, but we can solve this using a formula. So for a geometric series, right, because we are multiplying to get each term, and we're adding them all up. So geometric series S24 is going to be equal to A1, the first term is 1, times 1 minus R. R is 2, because we are doubling each time. 1 minus 2 to the N, 24th power, all over 1 minus, in this case, R is 2. So all over 1 minus 2. So because of that, we have 1 minus 2 to the 24th power. Let me just double check that we have 24 points. Okay, gotcha, 24. 1 minus 2 to the 24th power times 1. 1 minus 2 is negative 1 divided by negative 1. It's going to be 16,777,215. 16,777,215. Double check that answer. 16,777,215. All right, very good. Check it out. We're right. Clearing annotations. Ronald drops the ball straight down from a height of 5 meters. With each bounce, it rises to 3/5 of the height of the previous bounce. And so we have to read this very carefully. The ball drops straight down from a height of 5 meters. each bounce is 3/5 of the height of the previous bounce. When it reaches the ground for the 7th time, what is the total distance the ball has traveled? So let's think about this here. The ball starts out 5 meters above, and we're just measuring vertical distance, all right? So then, and just follow along, it falls down 5 meters for bounce number 1. Then for bounce number 2, it goes up, well, then it goes 5 times 3/5. So it's a little bit lower. And then it travels back down 5 times 3/5 for the second bounce. And then it does 5 times 3/5 times 3/5. So it goes up a little bit shorter. And then it comes back down the same amount for the third bounce. And the same thing, a little bit shorter for the 4th bounce. If you can visualize that, we're doing the same thing all the way up to the 6th bounce. All the way up to the 7th bounce. So, with that in mind, first, before we even have the first bounce, we have a height of 5. All right, we have 5. Now, after we have the height of 5, we can start doing our geometric series, because then we have 5 to the 2/3, and then we have another value that's also 5 to the 2/3. And then 5 to the 2/3, and so in fact, between the first and the second bounce, we go up 5 to the 2/3 and down 5 to the 2/3. So 5 to the 2/3, 5 times 3/5 times 2 could just be 10 times 3/5. So that's going to be 5 plus 10 to the 3/5 plus remember that's for bounce 1, then that encapsulates everything for bounce 2. For bounce 3, that would be 10 to the 3/5 times 3/5, or 10 to the 3/5 squared. This is when, so 5 is the distance it travels for bounce 1. Then before we get to bounce 2, when it touches the ground for the second time, it travels a total of 10 to the 3/5. For the third bounce, 10 to the 5th squared. The 4th bounce, 10 to the 3/5 cubed. So notice, each bounce, the exponent is less than, is 1 less than the bounce number. So what we can do is we can set up, keep on going, 5, 10 to the 3/5 to the 4th, plus 6, 10 to the 3/5 to the 5th, plus 10, that's the 6th bounce, and the 7th bounce is going to be 10 to the 3/5 all the way to the 6th power. Now, by the way, this is supposed to be a 3 and this is supposed to be a 5. So a lot of exposition here, but you can fast forward if you're having trouble understanding this. We can set this instead of adding this all up in our calculator, we can set this up as a geometric series as 5 plus a geometric series where we have 10 to the 3/5 as our common ratio a bunch of times, or specifically 6 times, right? So we have 5 plus, remember Sn is A1 times 1 minus r to the n over 1 minus r. And so A1 should be 10 to the 3/5. That's our first. That really is the first term in this series. And each term gets multiplied by 3/5, so that's going to be times 1 minus, well, you're still multiplying by 3/5 each time. 3/5 to the 1, 2, 3, 4, 5, 6 over 1 minus 3/5. So this is our final equation, and this just requires a bunch of abstract thinking. You have 5 plus, let's add the 5 at the end, okay? So we will have 1 minus 3/5 to the 6th power. .95334. Then we multiply this by 10 times 3/5. So this is multiplied by 10 times 3/5. Uh, 5.72. Then we divide this by 1 minus 3/5 is going to be 2/5. Divide this by 2/5. 14.300. And then we would need to add 5. So 19.30. 19.3. Hopefully we did that correct. Yes, we did. I encourage you to also look at the step-by-step solution, because Khan Academy has a pretty good explanation of it, where you really see it's 5, and then you add the 5, and then you look. It shows you how to break it down into a geometric series. Okay. So it really breaks it down, uses the formulas. So the hints are valuable here. So once again, 5 plus 10 to the 3/5. That's A1 times 1 minus 3/5 to the 6th. So let's show that summary. Everything's correct. And have a great day.